Okay, so let's look at what we got up here. Start at the lathe on the Program tab. We'll start at the top left corner and work our way to the right. So for the lathe operation, we just set our travel limits for the lathe. We have them set to 24 inches, negative and positive. And for the post, we have a post set up specifically for this webinar. It's a version of our FANUC post. In most cases, the FANUC is going to be the most common 2.5 axis turn center controller. So we're using the FANUC controller here. And really that's all we need to do. Make sure it's set to legacy post and we got our post selected. Now for the part, we mentioned that we drew our profile ahead of time. If you have a three-dimensional part that's a surface model and it's completely revolved already, you can use that. Just use the part solid section of the dialog and select your solid geometry, and it will calculate and draw this profile for you. Okay. In our case, we're going to be using the part curve section because we already have our profile drawn. So let's go ahead and remove that. And we just select our curves. Again, this is a closed curve all the way around. We're just going to pick our curve, right click, and we got our profile set up and we're going to pick save. So here you see we got the turn part silhouetted, defined, and here's our profile. Okay. So we're going to do most of our work in this top view. Okay. So let's go to the stock. We'll go up here and do a cylindrical stock. And we have our stock dimensions set to 2.22 for the radius. And we got 4.89 for the length. So it's a fairly good sized part. And the reason the part is this big, because you need, if you're going to do any ID turning, you need to have enough room in there to get your insert and your tool holder in there. If you cannot get it in there, you're going to have to do all of your ID cutting with drills. And you can do that too. I mean, you can get a drill in practically any size, just calculate the sizes you need, and you can drill this out just as well as finishing it. So we got our stock set, XYZ0, okay? So the back of our part, even though we extended it out, the back of the part now is lined up with the Y. The center line of the geometry is lined up with the X, okay? So that's very important. It has to be that way. So let's go ahead and we got our setup. Let's go ahead and do the machine 0. So this is a point where typically on a 2.5 axis lathe, the chuck and the spindle is on the left end or the left side, and you're going to zero out on the right side face of your stock that's sticking out of your chuck. Okay, so we have the work 0 set to the stock box and set to the rightmost side. I'm going to generate that. So here's parting off the right side of the part off tool at this back point. Let's go over here and rotate this around so we can see it. And we'll simulate this. Looks like we got it right to the end, Joe. Any questions?
Actually, there was a question on the machine setup. Do you just want to talk about the machine dialog? Yeah.
Yeah, so basically you're entering what your travel limits are, and your machine manufacturer in the manual, it'll tell you what those are, and just make sure you match those limits. And during simulation, if you pass those limits, okay, you can get it to flag for you. If we go, there's a checkbox here to stop simulation on error. So if there's any reason your insert or your tool path violates the machine limits, it'll stop and it'll warn you. So that's a good thing to know. Just make sure these are set up accordingly. And you also have a tool change point set to 10 in the X, okay? Anything
Yeah,
else?
that tool change point that tool change point can be used in the post processor. It's typically not really used in the toolpath generation itself, but it can be sent over to the post, and the post can be modified to use it.
Yeah, right. And
Last part, posting. Posting was the other question.
Yep.
Do you want to
Okay, let's
show
go ahead
post?
and simulate this real quick, then we'll do posting. We're gonna just do it from the start. There's our OD roughing, OD finishing, roughing. There's our finishing passes on the outside. There's our groove, our starter hole, our roughing hole, and a roughing hole, a roughing, and then finishing, and there's our threads and the parting off. Okay, let's look at the post. So we have the post set to FANUC. No, looks like we didn't have it set to FANUC. Let's go down here. I have a post.
Program data.
Yeah, I have a post here. So I have a FANUC AMS webinar post. And again, we have many FANUC posts in our list here. The default folder where the posts are in your product, I just changed the default folder to my working folder. But you have a whole list of posts. I think there's like 10 or 20 FANUC posts in there, Joe. Correct me if I'm wrong. Most popular 2.5 axis turning post. Okay, so we got that set. We're going to go ahead and post this. So here is our G code, and it's got all of the operations listed from start to finished, but have a particular note. Let's look to see if we can find our G76. So here is our G76. That's our thread, one line of code for the entire thread. Okay, and pretty much, I believe that pretty much any turning 2.5 axis turning center and controller that you have will probably support a G76, which is the most popular threading operation in there. Any questions on posting, Joe?
No, I think that's it. I think we're pretty much done with it, right, Don?
Yep.
Okay, all right. Thank you all for attending, and we'll send out the cleaned up video once we get a chance to do it, and then we'll see you next month for our next webinar.
Also, I wanted to mention that we are having a blog post on turn threading that will be coming out soon, probably in the next week or so. So keep an eye out for that as well. Goes into a lot more detail. Thank you, everyone.
Take care. Bye-bye.